Picture this. It's 1942. The world is at war and Europe is under the iron fist of Nazi Germany. Allied leaders know they need to launch a massive invasion, a decisive blow from the sea. But there's a colossal problem, a logistical nightmare that could doom the entire operation before it even begins. How do you supply an army of hundreds of thousands of soldiers on a hostile shore? You need tanks, trucks, fuel, ammunition, food, medical supplies, millions of tons of it. The Germans knew this. They had fortified every major port on the French coast, turning them into death traps. Cherbourg, Le Havre, Calais, all bristling with concrete, artillery and machine guns. A direct assault on a port would be a bloodbath. So, the Allies had to land on the open beaches of Normandy, but beaches are just sand and water. You can't just drive a 10,000-ton cargo ship onto the shore. Heavy supplies would have to be transferred to smaller landing craft, a process that was slow, inefficient, and dangerously exposed to enemy fire and the notoriously bad weather of the English Channel. The problem seemed unsolvable. At a high-level meeting, one frustrated officer reportedly slammed his fist on the table and declared, "If we can't capture a port, we must build one." It was a desperate, almost absurd idea. How do you build a harbor on an enemy beach in the middle of a war? This is where our story truly begins, with a man you've probably never heard of, Major Allan Beckett. He wasn't a general or a famous strategist. He was a quiet, unassuming civil engineer from East London. Before the war, he designed bridges and docks. Now, he was tasked with solving an impossible engineering puzzle that held the fate of the free world in its hands. The grand vision was called the Mulberry Harbor. It was a staggering concept, a massive, prefabricated portable harbor that would be towed across the English Channel and assembled off the coast of Normandy. It would have outer breakwaters to calm the waves, piers to unload ships, and most importantly, roadways to get everything from the ships to the shore. This last part, the roadway, was the trickiest piece of the puzzle. It had to be strong enough to support the weight of a 30-ton Sherman tank, but flexible enough to rise and fall with the dramatic 20-foot tides of Normandy. It needed to be a floating bridge, a steel serpent connecting the sea to the land. Dozens of designs were submitted. Most were complex, rigid, and impractical. They would snap under the constant stress of the waves and tides. The project was stalling. The clock was ticking towards D-Day. Then came Allan Beckett's idea. It was so simple, so elegant, it was almost revolutionary. He called his design the whale. Instead of fighting the power of the sea, he decided to work with it. His roadway was made of individual 80-foot steel sections or spans. These spans rested on floating pontoons, but the genius was in the connection. Beckett designed a special joint, a kind of steel knuckle that could twist and flex in 3 dimensions, just like a human wrist. This allowed the roadway to undulate with the waves, to rise and fall with the tide without breaking. It was a bridge that could breathe with the ocean. He also designed the roadway spans to be torsionally compliant, meaning they could twist slightly along their length. This further reduced the stress on the structure. When Beckett presented his design, the skeptics came out in force. Senior engineers, many of them far more decorated than him, scoffed. They called it flimsy, a clothesline. They were used to building things that were rigid and immovable, a bridge that was designed to bend and twist. It went against everything they knew. They believed it would collapse under the first heavy truck, let alone a column of tanks. One critic famously said, "The spans will have a life of about 5 minutes in the choppy waters of the Channel." The pressure on Beckett was immense. He wasn't just defending a blueprint, he was defending the key to the entire invasion. But Beckett was quietly confident. He had done the math, he had run the tests. He built a scale model and tested it in a water tank, simulating the harsh conditions of the Normandy coast. He knew it would work. Fortunately, a few key leaders saw the brilliance in its simplicity and gave him the green light. The project went into overdrive. In a colossal secret effort across Britain, thousands of workers began fabricating the components of the Mulberry Harbors. Concrete caissons the size of apartment buildings were constructed, giant floating breakwaters were welded together, and over 10 miles of Allan Beckett's whale roadway were manufactured. It was one of the greatest engineering feats of the 20th century, hidden in plain sight. On June 6, 1944, D-Day, as Allied soldiers stormed the beaches, a strange armada was crossing the channel behind them. Tugs were pulling the giant pieces of the Mulberry Harbors. Within days, 2 massive artificial ports, one for the Americans at Omaha Beach and one for the British at Gold Beach, began to take shape. And the whale roadways? They were the arteries. Towed into place and connected, they formed floating highways stretching from the pierheads in deep water right onto the sand. The moment of truth had arrived. Would the flimsy clothesline hold? The first jeeps rolled onto the spans, then trucks, then ambulances carrying the wounded, and then came the tanks. One after another, 30-ton Shermans rumbled across Beckett's flexible bridge. It held. It didn't just hold. It performed flawlessly, rising and falling with the tide, flexing with the waves, just as he had designed. Within 24 hours of being operational, the Mulberry Harbors were unloading thousands of tons of supplies per day. Beckett's impossible idea was now the lifeline of the Allied invasion. Just a couple of weeks later, a catastrophic storm, the worst in 40 years, slammed into the Normandy coast. It raged for 3 days, with gale-force winds and monstrous waves. The American Mulberry at Omaha Beach, which had been assembled more rigidly, was utterly destroyed. It was a devastating blow. But at the British harbour, something amazing happened. While other parts of the harbour were damaged, Allan Beckett's whale roadways survived. They twisted, they bucked, they flexed, but they did not break. They rode out the storm. After some quick repairs, the British Mulberry was back in business, and for the next several months it became the single busiest port in the world. Through this one harbour, over 2.5 million men, 500,000 vehicles, and 4 million tons of supplies poured into France. It was this endless stream of men and material flowing across Beckett's floating roads that fueled the breakout from Normandy and the eventual liberation of Europe. Allan Beckett's invention didn't just work, it changed history. It was a testament to the power of innovative thinking, of daring to defy convention. While the generals planned the battles, it was a humble engineer with a brilliant idea who built the bridge to victory. His name isn't in most history books, but every time you see a picture of the D-Day landings, remember the invisible lifeline that made it all possible. A single, simple, impossible idea that turned the tides of war. Thanks for watching. If you found this story as incredible as I did, make sure to like, subscribe, and hit that notification bell for more hidden histories. See you next time.